Hello, I'm Andy. I'm working on B-Dance for Andrea Greenlee's, and I wanted to do a quick video on how I fabricated the eyes. Got a lot of interest over the weekend over it, so here we are. The eyes are made from 1/4-inch pin rod, bent into these elliptical curves, and they're deep. Both Andrea and I agreed that the eyes should be really deep, but it's a tricky form to fabricate, so I'll do a quick video on how I did that. All 1/4-inch pin rod. These two are only tacked together, but show you how the rod was bent and how it was tacked into these forms. So all the bars are spaced 2 inches apart, and let's go look at the form. So the form took about a week to design. It's all MDF slotted together, and the rods are bent over the slots. I initially thought I'd use a slicer, which came out of 123D Make. Problem with slicer is you can only do a grid 90 degrees to each other, and for this it was really important that the angles were 60 degrees to each other, so that meant a whole lot of extra work in doing this manually. It's a slot together design. This is one of the test pieces. You can see that there's a groove routed on the edge that gives the rod a space to lay down in. One of the design challenges was that there's 2 layers of rod here. These guys are below these guys, and it would be a little bit easier if you look at the top one. When you're going vertical, you only need to go a 1/4 inch down, but when you get to this edge, you go a 1/4 inch down, you're still going to have interference with the top layer. So each of these curves offsets had to be manually adjusted in order to get the height in there. I initially thought about using a threaded insert into the side here that could then get bolted on to clamp the rods in place. That was going to take a long time and get tricky in spots where you had 2 rods coming into each other. And so what I did is cut a piece of 1/8 inch plate and screwed that onto the bottom, and that allows all these rods to get tack welded. So short end gets tack welded, the rod is sticking up, and it gets bent over and pulled to the other side, and then tacked on the other side. All these holes, I wasn't sure how much additional clamping was going to be needed to lay these flat as it went in there. And you can see on this one here I used a little bit of wire in order to hold it up, because this one wants to pull out from where it leans on that guy. Once it's all welded in, have this retaining ring, and flop this on here. So this retaining ring drops down and keeps it from springing out when it gets cut at this line here. Part of the problem is the steel has plastic and elastic properties. Now, elastic means how much is it going to spring back. Plastic is how much permanent deformation, how much curve is left in there after you bend it out. Trying to figure out how much to overbend so it would spring back to the right size was going to be nearly impossible. It'd be easy on a single piece, but doing it on this network, once it's all welded together, that system, being able to predict that was going to be really difficult. So the retaining ring holds things in place. While it gets cut off, the whole thing gets moved up and over and set on top of the base of the eye. So this one's welded out. Use 70S to weld on the bottom, and then silicon bronze in all the intersections. The silicon bronze is a lot less heat, and so on that MDF fixture, it's allowed to I can get in there without cooking the fixture too much, because the MDF off gases, and those off gas will screw up your weld. Let's see here. So let's go over the computer and show you some of the design. So actually, let's start over here. Nope, let's start this one. Alright, so the rods are modeled that way, but in order to get to where the rods are, we started off with, actually, let's open this guy, half an ellipse, and that half of ellipse was then revolved over in order to make this ellipsoid. So once had this ellipsoid shape, let's see, turn off that, and let's see. So once that ellipsoid shape was done, a grid 60 degrees to each other was laid out, and then projected up onto that 3D shape, onto that ellipsoid. Once I had these lines and planes on those lines, I could extrude those lines out into these elliptical shapes here. Now once on this elliptical shape here, it took a lot more massaging in order to get what we needed. All the slots had to be individually put in because of the 60-degree angle. All the holes for the clamping and all the little dog bone pieces in there had to be put in. Turn on the other side. So all those guys put in, and you can kind of see on the bottom here how those slots work, so that they're touch on the corners, but they're wider than the 1/2-inch MDF in order to get it to fit. From here, once all this work was done, and actually on the groove, I'll show you guys that. Those grooves were cut on the CNC router with what's called the canoe bit. And I'll go over to, yeah, this guy here. Is this the one? Nope. Maybe it's this other one. No, it is this one. I think this is set up too. Yeah. So you can see all the tool paths, all those pieces got laid out and cut out from there. And skip ahead. So all those pieces cut on the router and then slotted together up and fit onto the base. So that's kind of in a nutshell, in a 9-minute video, I guess, on how this fixture was made to bend the eyes on B-Dance. And B-Dance will be at Burning Man 2019, and I hope everyone gets to climb it. Thanks for watching.